Good afternoon, everyone. Should I start with the presentation?
No, please wait for your turn. We'll call you when it's your
Okay,
turn.
sure. Thank you.
Hello, everyone. Good morning, afternoon, or evening. Dear authors and invited guests, welcome to Technical Session 1011B. My name is Alesha Mulla, and I will be your moderator for today. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Sustainable Development, ICT4SD 2026, in Goa, India. The 11th edition of the conference is being organized in a hybrid mode. The physical event was held in Goa on the 9th of July, and the virtual event is being held from 9th to 11th July 2026 via Zoom. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we will have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for question and answer. On the 9-minute mark, I will raise a gentle reminder. There is another request to all the participants. Please stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Before we start the session, I would like to introduce you all to the chair for today's session. Dr. Hemlata Vivek Gaikwad is an associate professor at the Symbiosis Institute of Management Studies, Symbiosis International Deemed University, Pune, India, with over 17 years of academic experience. Specializing in leadership development, diversity and inclusion, behavioral sciences, and change management, she has published widely in Scopus Index journals. Welcome, ma'am. I request you to please say a few words.
Very good afternoon, everyone. And thanks a lot to the organizers for inviting me as a session chair. And I think, with the past year's experiences, it is always a great experience to listen to all the learned scholars and the faculty members who are presenting over here. And at the same time, I feel that for everyone, it is a learning experience. We can learn from each other's research and understand what is going on in the community and the research arena. So, thank you so much. And I think we can start now.
Thank you, ma'am. Let's begin with the presentations. Our first presenter for today is Sanjeevani Mane, who will be presenting a comprehensive study and review on Shvasa Shlokas in Ashtanga Hridaya and its interpretation. You may now begin your presentation.
Uh, Hi, ma'am. Am I supposed to start?
Yes, you may.
Okay.
Yes, Sanjeev, you can start.
Yes, ma'am. Yes.
Please share your screen.
Yes, ma'am. I'm trying to share, but Ma'am, is it visible?
Yes, it is.
Yeah. Good afternoon, respected judges, professors, and everyone present over here. Myself, Sanjeevani Mane, from SPPU. I'm going to present my research work titled with a comprehensive study and review on Shwasa Shlokas in Ashtanga Hridaya and its interpretation. Just a minute, I will minimize this. In today's presentation, in next couple of minutes, I'm going to cover all these points, starting from the introduction till references. So we'll start. Actually, my research area is Sanskrit Ashtanga Hridayam, which is in Sanskrit, and I'm working on the same. In 7th century, Ashtanga Hridayam is the Sanskrit Ayurvedic literature, which is introduced by the Vagbhatta, and it covers. Actually, there are total 8 branches of the Ayurvedas related to the surgery, medicines, various diseases, and all, and herbs and all these 8 branches of Ayurveda. They are designed in total 6 sections. All these 8 sections of the actually Ayurveda, they are designed in a total 6 chapters or the 6 sections in Ashtanga Hridayam. So, total 8 branches of the Ayurvedas are Kaya Chikitsa, Shalya Tantra, and all these are, I think, there's in next slide also. Yeah. So, Kaya Chikitsa, Shalya Tantra, Shalakya Tantra, and till Vijay Karana. So all these are the main 8 branches of the Ayurvedas. They are focusing on the surgical part, treatment part, all the parts of the bodies, and from mental health to the physical health related to all the parts of the bodies, herbs and all. So all these 8 branches, they are covered in ancient literature Ashtanga Hridayam in 6 thanas actually. That all these are the categorized, and Ashtanga Hridayam is the ancient literature which covers uh, like various sthanas like Sutrasthana, Sharirasthana, Nidansthana, Chikitsthana, Kalpasthana, and Uttarasthana. So here, each and every sthanas or the chapters or the adhyay from the Ashtanga Hridayam which covers or which focuses on the various parts of the health and diseases and etc. So here, actually it's very big Ayurvedic literature which covers around 7,000 Sanskrit shlokas, and through all these 6 sthanas. So out of them, I'm going to work on the Shwasa related shlokas, and those are mostly covered in the Nidan sthana and Chikitsa sthana. They are highly relevant Shwasa related shlokas are there, and those are less related or the indirectly related at some part in my research work. They are covered in the remaining sthanas. So yes, so this is introduction, and the motivation behind to choose this particular topic is the since COVID, respiratory disorders are increased a lot, and yes, that is the main reason. And as we are having very important, detailed, and very systematic description of all these problems, health related problems in our ancient literature, but it is written in Sanskrit, and it's in very complex and difficult form. That's why it is less accessible. So I'm just trying to make it more accessible by making it computational, so that it will be more accessible, it will be more used, and it may be used more, and which will help us. So that is the motivation behind the same. Now, what is the problem, ma'am? Actually, nowadays, English, like Ashtanga Hridayam, so many Ayurvedic websites, Ayurvedic colleges, and Ayurvedic organizations are there. They're having all these things, but like uh, even though there is a the Sanskrit, that difficult Sanskrit or the complex form of the Sanskrit is available, and its translation is also available. But what is the problem? Even though that particular translation is available in English, and even though it is easily accessible and understood, but the problem is that uh, like for a particular word there are multiple meanings with different context. For example, this particular shloka is saying that ki light food will improve the strength of the body digestion. It will improve the digestion. It will improve the indirectly other parts of the bodies. But here in this particular shloka, actually fire word is there. So that fire can have the multiple meanings. With respect to the different contexts, fire can be interpreted in a different way. So that is the problem with the plain translation which is currently available in on various websites. So that here I'm trying to make it like a proper Ayurvedic description related to a particular problem with a like very specific description. So it's not going to be a plain translation. Like Agni or the fire can be understood or interpreted with respect to the different context in a different way. So here fire can be considered as indirectly, it can in general in real life fire can be considered as a light lamp, uh, light in the darkness. Then so many meanings are there. But here we have to here we are trying to figure out fire is nothing but here that particular urja in Ayurveda, or the heat which is needed for the digestion. So that we need to make computational, and that is the need here. I thought that's why I'm trying my level best to fetch the Sanskrit part related to the shwasa from Ashtanga Hridayam and make it computational so that it will help us. Yeah. So here my problem statement is a comprehensive study and review on Shwasa shlokas in Ashtanga Hridaya and its interpretation. And below are the objectives listed, which cover study the interpretation challenges. Actually, that is very important part as it is very difficult. Old Ayurvedic literature like Charak Samhita and all, they are very tough to understand. So there are so many Ayurvedic experts are there. Those are called as commentators. So they're having the commentaries to make it easy, convenient in a simple language with so many examples from the old ancient literature, so that it is going to be understood by the people like us. So I'm going to use those commentaries also to while doing annotation and all. So here after that, after fetching the shlokas, I'm trying to analyze with respect to the language, with respect to its semantics, multiple meanings, with respect to the different contexts. So that covers the interpretation part. And after that, I'm trying to make like we need to get the guidance from the experts also. And yes, that is now what is the problem here? The knowledge is available, plain translation is also available, but the research gap is that that particular knowledge is not in a computational form which will be understood by the system. If I want to design one system and I want to train that system, that plain English translation will not make it more accurate with respect to the different context. So that is the problem. And I thought that I faced this particular research gap, and I'm trying to propose computational framework to interpret the Shwasa related shlokas from the Ashtanga Hridayam. So this is the problem statement and these are the objectives. Next, abstract covers there are so many diseases and so many problems are there in that list described in detail in Ashtanga Hridayam. But I picked Shwasa, and yes, so I'm going to what exactly we are going to do here. We are trying to fetch the Sanskrit related shlokas. We are going to pre-process that particular data through the various pre-processing techniques like tokenization, lemmatization, morphological analysis, grammatical analysis, breaking it into the words and rest of the part. And after that, the main part which will that is the main part of the research work is that the annotation with respect to the semantics. And
Excuse
after that,
me. I'm
yes,
so
ma'am.
sorry to interrupt. You have 1 minute left.
Okay, so this is abstract. And yes, ma'am, in literature review, I have gone through the various paper. Those are working on the Sanskrit along with the NLP and Sanskrit, Ayurveda and Sanskrit, and pure Ayurveda, in which Shwasa is treated as a tamak Shwasa problem, and in modern medical science, it is treated as a bronchial asthma. So yes, so in proposed methodology, we are fetching input from the Ashtanga Hridaya. We are pre-processing that text, and after that, we are doing semantic analysis, and we are trying to map that text through the reports, through the knowledge graphs, through the entities and relationships, like for which disease, what symptoms are there, what treatments are there. So in report, we are trying to see the knowledge graph. And this is the sample example while going through the papers in literature review. So all these are the entities and relationships among them. And herbs are mentioned here. So in our case, we are trying to focus it on like diseases, symptoms, and causes behind the same, and the medicines for the same. So likewise we are trying to do. And yes, these are the various applications in upcoming AI based health related applications. It can be used as we are making it computational. We are provide preserving ancient knowledge. And yes, it is going to help for decision support for Ayurvedic practitioners also, and it is going to help to Ayurvedic students to learn easily. And yes, in conclusion, so this is what we are concluding key. We are trying to make the ancient knowledge computational, and we are trying to make it more accessible. We are trying to preserve it. And yes, and we are going to design the health related applications which will help Ayurvedic practitioners. Yes, so this is conclusion. All these are the key references I used in my research work till now. Yes, thank you so much, ma'am, and I'm happy to answer the questions. Thank you.
Thank you, Sanjeevani.
Yes, ma'am.
And a very interesting research. And I
Yes.
think this is part of your doctoral research, as you mentioned.
Yes, ma'am. Yes.
I just wanted to know, like, what is the final outcome you are trying to achieve? Like you said, you are analyzing the text, that means the content analysis, and you are preparing these knowledge graphs. So,
Yes,
what
ma'am.
will be the implications of your research to the other research community, academics, society, and government? Can you just throw light on that?
Yes, ma'am. So actually, what is there are so many old ancient Ayurvedic literatures are there in our history, literature history, but they are very less accessible because they are very tough to understand. And we it seems ki English translation is nowadays available, but that is the plain translation. It's not with respect to a particular context. It's not a computational data set. So in my research work, I'm main work is like annotation part, like semantic work. Ki whatever the input we are getting, we have to annotate it properly with respect by taking the guidance from the various commentaries, Ayurvedic literature, Ayurvedic expert people. And for each and every word from that Shwasa related shloka from the Ashtanga Hridayam, like with respect to the different context, I want to provide the multiple meaning. So it is going to be computational data set which will help if in future if we are trying to design AI based something, or in research work also, if it will be needed, so they can use that. And yes, for Ayurvedic student
Perfect,
also.
perfect. And
Yes.
are you using any software?
Not yet, ma'am. Still, research work is going on, because what is the problem? Pure Sanskrit and Ayurvedic based work is there. Sanskrit and NLP work is also there. But Sanskrit and Ayurvedic work, interpretation work, that combination is very rare and few. And that is the gap I understood, and I'm picking the same.
Understood, understood.
Yeah.
Thank you, and very good. I hope, wish you all the best.
Thank you so much,
And thank
ma'am.
you so much. Yeah.
Yeah. Thank you.
Thank you. We'll now move on to the next presentation. Our next presenter for today is Shraddha Ghule, who will be presenting Community Issue Reporting and Prioritization Portal. You may now begin.
Hello.
Yes, you're audible.
Is my screen is visible to you all?
Yes, it is.
Wait a moment. Wait a minute. So, very good afternoon, all of you. This is the Community Issue Reporting Portal and Prioritization. The authors, we are a team of 5. Paurus More, Shraddha Gule, Sakshi Bhosle, Shailaja Menon, and Professor Savita Loya. As we see that in our nearby, in daily life, we see a lot of issues while walking, while moving around. That is, open manholes, garbages are there, potholes are there, water leakages, fallen trees has been there. A lot of issues the citizen is facing. So we seen that this is the issues where the authorities and municipal corporation is looking at it, but the citizen, if the citizen wants to report it, there is a no centralized platform where citizen can report the whatever the issues they are facing in a daily life. Might be authorities don't know what are the local people are facing this. So the target audience is citizens and the municipal corporates authorities. This is the existing systems and the research gap. We found that there are a lot of research as there where they using the deployable AI based system. Uh, they are seeing the issues like we have classified, we have looking forward the 7 issues, but uh, in the past research paper we have seen that many of the researchers are only looking after the 2 or 3 issues, and they're making and training their models. But we have seen we want to gather most of the valuable issues, that is of 7 issues we have classified. In the previous research paper I have seen that is a manual processing is going on, and there is no severity assessment. If the in the municipal corporate in municipal authorities, if the 205 or even the 10 or 15 citizens have reported the issues, but we need to classify the issues, that what the report the authorities should given the priority and to resolve basis upon their severity. And there is no tracking system. Limited issue types are there, as I have mentioned earlier also. We have find this gap, and we tried to create a one central platform, and we used AI, and also we used a machine learning so extensively. This is our system is there, where the community we're using it, and it's very handy. It's not a confusing one, like a unlike a social media platform. Is the same as an more likely an Instagram post, where the people posting and other of the followers, mutual people can see that post. Like that only, the if I'm posting any of the issue, the other citizen also came to know, yes, this person have reported this issue, so they can upload, they can like it. So how this is workflowing going on, I will explain it in a minute. The portal takes the images, like a citizen can take a photo, they can describe it in the form of the text, or they can use a voice. So within a second the description will be captured, and then a geotagging has been there, means then and there the location of an a citizen is been captured. And this captured location has been shown on the map itself, the map. So authorities can see a map, and they can see, okay, in this area this issue has been reported and by this citizen. Now the how as soon as the if any of the image the citizen has been uh, capturing, the MobileNet V2 image classification model, this model we have trained, that model classifies the issue within a second. And if the 2 or 3 people reporting the same issue, so we have a duplicated detection. It is we have used a p hash, where the image has been captured, converted into grayscale, and the same features has been extracted, and we can compare it and can eliminate the repeated issue reporting. And a Gemini API, we have extensively integrated the Gemini API, uh, which can tell the priority, means the severity of the issue. And this all data goes to the authority. So authority comes to know this issue is reported, duplicate detection is done, classification is done, and this is a very real one, and the work has been started. So we have tried to maintain the transparency also. So people will come to know about what is going on in the authority backside also. There is a more and more transparency. So we let's come to the dataset model. So here we classified the 7 issues, that is a garbage, fallen tree, pothole, open manhole, street light, broken benches, leaky pipes. This is the major of the issues we frequently often see in our neighborhood places. We took the images lot. This as the images count we mentioned in the front of the issue. Then we did augmentation, rotation, horizontal flip, brightness shift, and we use the mobile net v2 model, and we put the image size 224 into 224. Then we split the data for the training and another for the validation. So after this, the MobileNet V2 model classifies, achieve it's a 89% accuracy is there. They have tested it, and the P has, that is a duplicate detection, has a 91% of accuracy of detecting the duplicate uh, duplicated issue that is posting by the people. And AI priority is very important because we have to look forward that what is the severe reports has been reporting by the issues, and we need to look forward to resolve it. That is a authority side. Authorities can be a municipal authorities, it can be our local authorities. We can integrate it later in the future. It can be also used in the schools and the colleges where the students faces issues. So based upon that, we can change the categories. Like we can uh, change the categories what the student faces in the colleges. Okay. So our conclusion and the future work is that developed a portal that is enabling the citizen to report and prioritize community issues and AI-driven prioritization, and which is very handy. People can use it in the mobile. It's very much easy because people are used to do a social media. Unlike that, this is one of the kind of similar to them. They can no need to another. They can use it very goodly. And the real time notification, the email is also there. As soon as I reported one issue, if the issues get resolved by the authority, I can get the email. The notification also is there. And we have embedded the gamification where the issues where the report citizen get the points on the reporting their issues. There is a more engaging platform, and this this how this transparency create a pressure on the municipal, because we have created like a social media platform. Everyone who is in that using that platform came to know about another people's issue, what they this person is reported, what that person is reported. So this create a pressure that to the authority, so they have pressure to resolve it very fast. We are focusing on the future direction, that multilingual support using umbert, more civic issue categorization, more balanced data, because now there is an a role low recall is observed for the leaky pipes, that is 0.65, because there is a less images for the leaky pipes categorization is there, and partner with the local governments for the large scale deployments. Okay, so thank you. This is all about our research, our creation. Thank you. Proceeding for the question and answers.
Yes, Shraddha. You have, as I can make out, you have made, is it a website or an app which you have made application?
Right now, it is in a state of website. We are looking forward to make an app, a web app.
All right. So is it live?
Yes, it is not yet. It is not deployed because we want to work on the local storage, and the people are posting the images. So we want to work on that.
Okay. So then how are people posting images if the website is not live?
I have some of them. Give a second. This is the images you can see, like our prototype. Is it visible?
No, no, it is not.
Okay, okay. Ma'am, it is visible.
Yes, yes, it is.
So this is the how you can see the left side at the corner. That is a status also there. I mean, what is the current status?
Okay.
Okay.
All right. So, so when are you planning to launch the beta version of the website at least?
In upcoming 3 to 4 months, we are planning to launch this version.
All right. Any funding available for your this thing project?
No, ma'am, no funding. We are doing it our own level. There is no, we are haven't reached our hands to get a funding from others.
All right. A good initiative. Yeah.
Thank you.
Thank you.
Thank you, ma'am.
Thank you. Yeah.
One moment. We'll now continue with the next presentation. Our next presenter for today is Adarsh Gupta, who will be presenting Hybrid and Ensemble Learning Framework for Robust Faulty Sensor Node Detection in Wireless Sensor Networks. You may now begin your presentation.
So is my screen visible?
Yes, it is.
So my research topic was design and development of hybrid and ensemble learning framework for faulty sensor node detection in wireless sensor networks, and this was a part of my MTech research thesis. So I was under Virendra Ranga sir, and my college was from DT. These are the outlines I will be covering: introduction, related work, research gap, my work and result conclusion, references, and my first paper publications. Coming to the introduction, wireless sensor network generally consists of the distributed and autonomous sensors to monitor physical and environment conditions. And sensors generally act as node and communicate data wirelessly to the base stations or the central hub. Generally, we face the challenges is that it has limited battery life, constraint power, and susceptibility to harsh environment. So detecting it in early stages it's most important. So there are almost two types of faults in wireless sensor networks. These are the soft faults and the hard faults. Soft fault generally consists of the noisy data output while it continues to operate, and in hard faults, the nodes are completely failed and it doesn't communicate to the any base stations. The motivation which I've coming to the motivation, wireless sensor network generally needs the automatic fault detection because the manual checking of every sensor node is very difficult and also time consuming. Machine learning can learn fault patterns from the sensor network without depending on the fixed threshold values. Single ML models may struggle with complex and non-linear sensor behavior. Thus, my model hybrid and ensemble models combine the multiple algorithm to improve the accuracy and robustness. The previous research related work on this topic was generally based on the threshold rules for detecting centralized voting and neighbor coordination mechanism. Basic ML models such as SVM, KNN, decision tree, and random forest improve the faulty sensor, but they doesn't have much better accuracies, and there was a large gap on this research. So in recent studies, the neural networks and uh, ensemble learning for handling nonlinear was there was a huge gap. Demerits observed in the related work was the lower accuracy first, and next was the higher resource demand. Generally, deep learning models require large data set and higher training time, whereas our data sets are not much larger. Uh, and coming to the energy constraints, heavy models are difficult to deploy in the wireless sensor network environment, where the sensor nodes have limited battery and processing capability. Coming to with the scalability demerits, methods such as B-scan and one class SPM can be computationally inexpensive for the large sensor data set. And research gap related has comparatively limited focus on the optimized advanced tabular ML methods such as XGBoost, which outperform based on the tabular data. And our data set was also similar, so it was the best accuracy that it gave us. And the research gap and proposed direction need for this, we need for model that balances the high accuracy with the practical computations and energy constraints of the wireless sensor networks. My model then first established the baseline ML for basic ML baselines, and then I extended it to the advanced models using multi-layer perceptrons, voting classifier, stacking classifier, and the XGBoost. Uh, Coming to the how models proposed model overcome the limitations. First, use the basic models like linear regression, SVM, KNN, decision tree, random forest, and these became my baseline. After that, I use the advanced ML studies like XGBoost, multilinear plus perceptron, voting, stacking are evaluated to capture nonlinear. The accuracy, XGBoost achieved the best accuracy, that was 99.15 percentage. And the main reason was because of the structured data and the tabular data, and thus it avoids the heavy data requirement and of the deep neural networks. And this achieved the novelty in my case. Coming to the architecture, sensor networks generally consist of three layers. Perceptron layer, this is the sensor layer, where the nodes are deployed in the environment, and the data are the input to this system. Coming to the network layer generally the nodes that captures the data transmit the data to the base station, and each data are in the form of like have the sensor ID, time, type, sensor type, the coordinates, and sensor value, and remaining battery percentage. Coming to the application layer, this is the processing layer where the base station executes the machine learning model to detect the faulty and non-faulty nodes. This was the flowchart of my model. Coming to the first was the data collection, where I collected the data from the Kaggle. That was the EDA wireless sensor network dataset. The dataset generally has the features such as temperature, humidity, pressure, battery level, sensor types, and connectivity information. Second step was the EDA, that was the exploratory data analysis. Before training the model, we understand the data. So, spatial distribution plot and classification distribution plot help us to understand the data. Coming to the third step, it was data cleaning and the feature scaling. Missing values and null values, handling null values were the major part. Then categorical encoding, which converts the text data into the numerical form, like temperature, humidity, when these were converted to the 0, 1, 2, and identifying the removal like and irrelevant features which were not required in the training the models. Feature scaling engineering is selecting the features which are important and extracting the features which are more useful, like temperature, humidity, pressure, sensor reading, voltage, battery life. Then coming to the next step was the train test split. We divided the data set into the two parts, training and testing. Generally, we do 80% of the training and data, and we divide 20% as the testing part. Then we had a baseline models, linear regression, logistic regression, KNN, decision tree, random forest. Then we have the proposed voting ensemble learning, that was decision tree, random forest, and XGBoost. We clubbed them and we saw the accuracy. Then coming to the stacking classifier, which on the first layer was the random forest, KNN, and XGBoost. Then their output was the input for the next level 2 layer, that was the logistic regression. And then we got a summarized accuracy for all these models, and we evaluated models based on the accuracy, precision, recall, F1 score, and then we got the result as nodes were faulty and non-faulty. These were the machine learning methodology I utilized here was the basic logistic regression, KNN, decision tree, support vector machine. And coming to the advanced and hybrid framework design, and so I use the multi-layer perceptron, random forest, gradient boost. That was the best in my case. And coming to the symbol combination, soft voting, which combines the random forest, decision tree, and exit boost. And its stacking architecture was includes the random forest, KNN, exit boost, and the meta layer, that was the second layer, was consist of the logistic regression. The dataset in my case was of 10,000 instances. Feature set was sensor type, date, timestamp, sensor type, as ID and spatial coordinates, sensor data, battery life remaining. And the target variable was the is faulty, where it represents 0 for the normal and 1 for the faulty nodes. Coming to the EDA, that was the
Excuse
target.
me. I'm so sorry to interrupt. You have 1 minute left.
Okay. Individual models, you told it before. So coming to the ensemble learning, it combines the prediction from the multiple models to improve the accuracy, and random forest reduces the decision tree overfitting, and XGBoost is the boosting framework that builds the sequential where the new trees minimizes the prediction based on the above previous flow. And the stacking of level 2 levels, that was random forest, execute, and KNN, and level 1 consists of logistic regressions. This for the environmental setup, where I use Python with library scikit-learn, pandas, numpy, and dataset split 80:20 ratio. Then evaluation matrix was accuracy, precision, recall, F1 score. Yeah, this was the result for the baseline models. That is, the decision tree has the best accuracy from in the baseline. Coming to the advanced and hybrid models, the XGBoost was the has outperformed the most of them, and it was 99.15%. Why XGBoost got the highest accuracy? Because of the structured and tabular data set. So this was the main reason. Yeah, so in future work, real-time fault detection, like developing adaptive system for the continuous monitoring and optimizing data processing, improve the efficiency in large and data set through the edge scaling, and we can scale the solution to the large and dynamic sensor networks. These were the references which I used, and this was the first publication of my research work, where I use the baseline models, and this is the advanced and ensemble learning hybrid model which I'm presenting right now. That's all. Thank you.
Thank you, Adarsh. And just one question from my side.
Yeah.
Like your XGBoost has inbuilt cross validation available.
Yes.
So because so that you can stop your training the model early. So is your model training over? Have you like the training data set which you have used, or you're still the model is under training?
No, the model was under training. So, but as I got the better accuracy, so I just stopped that and like rest of the ensemble models which I use, like stacking and classifier and the voting classifier. Among them, I saw that there was a dip in the accuracy. So then I considered the XGBoost as the um, like main model. So it gave me the best accuracy among them.
Right. And how did you handle sparsity?
Sorry,
How did you handle sparsity?
sparsity. Uh, Sorry,
Means
sorry.
whatever the
Mhm.
missing data or incomplete data was there when you were
Yeah,
training, how did you
so
handle that?
yeah, so I used their we used a library called scikit-learn, which handles and NumPy pandas also to handle them. And basically, I told in above slides like uh, we used this heat map analysis for the missing values uh, from the matplotlib library. So this way we handle the data missing values.
All right, understood. Thank you so much, Adarsh. A good
Thank you.
presentation.
Thank you. We'll now continue with the next presentation. Before that, I just want to give a gentle reminder. Please be mindful of the time and make sure that your presentation is done in 10 minutes and the Q&A is done within 2 minutes. Thank you so much. Let's continue with the next presentation. You may stop presenting. Our next presenter for today is Mandalam Chitralekha, who will be presenting Hybrid FarmNet, a graph transformer fusion framework with Bayesian meta-learning for uncertainty-aware drug response prediction. You may now begin.
Can I know that my screen is visible, ma'am?
Yes, it's loading. Just 1 minute. Yes, it's visible now.
Yeah, thank you. And a very good afternoon to the organizing team and panel members and the participants who are available in this conference. And this is Mandalam Chitralekha, research scholar at SRM Valliyamma Engineering College affiliated to Anna University, Chennai. And today I'm presenting my work titled Hybrid FarmNet, a graphical transform fusion framework with Bayesian meta-learning for uncertainty-aware drug response prediction. In short, this is a deep learning system that predicts how a cancer cell will respond to drug. In just importantly tell us how confident in this prediction. And coming to my introduction, we are in the era of personalized cancer treatment made possible by large pharmacogenome resources like GDSC, CCLE, and NCI60 panel. But even with all this data, predicting the actual magnitude of the tumor response measured as IC50, the drug concentration that kills off of the cancer cells, remains genuinely hard, high dimensional regression problem. And the reason it is like no single data type tells the whole story. Gene expression captures the dynamic state of the cells. Copy number alteration captures genome instability, and mutation captures the driver events of the oncogenes and tumor suppressions. And each of these is different lens and on the same tumor. And a good model needs an integral of all three, not just one. And coming to my problem statement and objectives, here this brings you specific problems we set out to solve. The first one is feature level fusion creates high multi-collinear representation, which actually hurts the model discriminative power rather than helping it. And coming to the next one, treating gene regulatory networks, that is static ignores real biological evidence that these networks rewire themselves between cancer subtypes and responsive in oncology events. That is nothing but the drug discovery, drug response predictions. And coming to the third one, this is a clinical bottleneck. Like virtual every widely used pharmacogenomic algorithms gives a point estimate only, not uncertainty. And without uncertainty information, clinicians have no principalized way to know what you trust the model when not to. And coming to my abstract, here the predicting drug response is one of the central challenge in precision oncology while we are facing now. If we predict it computationally whether the tumor will respond to given the drug, for that I have fixed as IC50 as a threshold. And here we can move to the treatment decision away from the trial and error method and towards something much more personalized. But the current generation of computational pharmacogenomic models that has some recurring weaknesses. The first thing is when we combine multiple types of biological data, which is nothing but multi-omics data, they usually just concentrate the feature together that ignores the fact that gene expressions, mutation, and copy numbers interact with each other biologically. And the next one is most the models represent gene regulatories like a static graphs, but real biologically doesn't work in the way of statical graphs. Here, the wiring of gene network actually reorganized between the cancer subtypes. So we built a hybrid net to address all these problems at once in hierarchical end-to-end framework, which is two branches of encoders. One branch is PPI attention network and the model gene-to-gene interaction, and other one is cross-model rotatory transformer that captures long range of interactions across omic data types. Here, drug molecules are represented using a pharmacophore augmented message passing neural network. We use sharply influenced feature selection method. We just call that as a SJST. We train with a Riemann manifold differential evaluation of the solver, and critically we attach a deep kernel learning Gaussian process ahead of uncertainty and qualification. Here, the result shows that the three benchmark data sets we achieved a Pearson correlation of 0.937 and AURUC of 0.961 and MCC of 0.756, FN score and ECA followed. And next coming, these are the related works I have gone through. First one is Amit Woodling kernelized Bayesian matrix like factorization approach was early multitask of method, but it trains cost scales cubically and it doesn't natively encode drug graphs. And coming to the second, Chang et al. Here they have went to CDR scan used twin 1D convolutional network over transcriptomics and Morgan fingerprints. An important first step is to deep learning for the problem. It is a single omic and fingerprint losses 3D pharmacophores information. And coming to Leo et al., deep ETO followed to hybrid graph convolutional network combining mutations, expressions, and methylone data, genuinely multi-omics fusion, but it is late post-hoc fusions and again no certainty here estimated. And followed TGSA introduced a twin graph neural network over protein-to-protein interaction graphs with similarity augmentation, enabling knowledge transfer across cell lines, but the attention mechanism stays confined within a single omic modality. And here it is a separately Wilson deep kernel learning work showed can get scalable calibral uncertainty estimate, but it had never been applied a multi-omics pharmacogenomics before. And coming to this is my proposed architecture. Here the data flow itself through a pre-processing and feature selection pipeline. The key innovation here is our SAST creation, that is nothing but sharply influenced Jason Shannon divergence. In a plain term, for every feature, we weight a Jensen-Shannon divergence between the sensitive and resistive class distribution by Shapley attention value. Here, sensitive and resistive, it is completely based on IC50 value. If IC50 is less than the threshold, then it is a sensitive. If it is greater than the threshold, it is resistant. Here, the class is distributed by itself for Shapley and attention values. That means we are selecting features that both statistically discriminative and casually important of the model predictions. And from this cell line, data flow in our two branch encoders. The first branch is protein to protein interaction graphical attention network. And the second one is cross model rotatory transform, which uses explicit attention to capture long range of interactions between the omic data types. On the drug side, we are using pharmacophore augmented smile based messages passing neural network. So the model isn't reading smiles string as a sequence. It aware of 3D pharmacophore features that actually drives a drug target binding. The whole thing here is trained end to end using Raman manifold differential evaluation solver that is very top sit and our deep kernel learning option process ahead, which is what gives a calibrated uncertainty on every single prediction. And this is the experimental setup. Here we have evaluated in three complementary data sets. First one is GDA-SCV2. Here we have around 800 cancer cell lines and 200 drug across 24 drug classes. Here RNA sequence over roughly approximately 17,000 genes, copy numbers over 22,000 features, and mutation data over 70,000. And coming to CCLE, here more than 1,000 cell lines with the expression and mutation AUC based drug response of 24 drugs. And coming to pharmacopdx, 399 patient derived xenograph treatment profile across 15 targeted therapies and 40 solid tumor types. This one matter a lot because it runs into view clinically relevant benchmarks, not just SLI. For evaluation, we have used five-fold nested cross validation and here threefold loop for hyperparameter tuning, and the outer fivefold loop purely generalized assignment, so there is no data leakage between the tuning and evaluation. And coming to evaluation baseline and metrics, here we tested three generalization scenarios, each harder than last: random split of cell line drug pairs and leave line line out, leave drug out. This one brings the toughest since the model has never seen a drug training at all. And we benchmarked against 10 baseline spinning classical methods like rich expressions and the random forest up to through deep learning models like DeepCD or GraphDB, DCCA, Molly, Magonate, and DeepTDA, etc. etc. And here we train by
Excuse
using
me.
NVIDIA.
I'm so sorry to interrupt. You have less than a minute left.
Yeah, sure, ma'am. I will try to complete. And here we are trying using NVIDIA 100 and GPUs using PyTorch 2.1 and PyTorch Geometric 2.4. And on the metrics, we tracked regression metrics like PCC and RMSE, classification metrics like AO and F1, uncertainty metrics like expected calibrations and Barry score, and efficiency metrics like training and interface times. And coming to the result and discussion here. The headline result across 9 baseline methods from ridge regressions up to the strongest prior deep learning model. MGGraph DTA hybrid format is the top of the every system, and the PCC here around 0.37 up and MGGraph approach 0.914. And here one of the improvement was statistically significant under the Waxton test I just mentioned, and I have highlighted the work of mine as a hybrid format here. And coming to here, The first panel set shows multimetric benchmarking of GDSA V2 group bar charts of PCC, AUA, ROC, F1 and MCC across 8 methods of significant bracket, RMSE and calibration error plotted together, where hybrid net wins to both axes simultaneously. That is not a trial. And coming to the second figure, there is a classification performance curves, ROC curves at 8 methods of 94% bootstrap confidence bond around the on model precision recall and curves. And coming to the conclusion, we proposed a hybrid format hierarchical graphical transformer framework Bayesian uncertainty avoid drug response prediction from the multimodal pharmacogenomic data. It integrates PPI graph attention network cross-model transformer pharmacophore awareness drugs and shapely based feature selection and deep kernel learning Gaussian framework. And these are my references I have referred. And thank you.
So thank you, Mandalam. And two questions from my side. Whatever biomarkers you identified, were they overlapping the earlier cancer-related genes, or did you identify any new biomarkers in your study?
Actually, I have not taken anything new. Actually, what I have existed, those biomarkers I have taken. Actually, my level of work is just based on the mutations, based on the gene sequence. After the mutation and copy number alterations, I'm just following those things. I'm not taken anything new.
All right. And what do you think is the biggest limitation of your model?
Actually, in most of the papers, they have mentioned the threshold, right? Here I have taken as IC50 as my threshold value. I'm not getting the accuracy which I have planned. I'm getting a more rapid. Actually, I have trained with many models. Because of vast data of genome, I can't able to cross more than 85% of accuracy. That is the biggest challenge I am facing now.
And how are you planning to work on it?
Actually, we don't have a proper workstation for genome lab. We have applied as a funding. If we get that fund, then we can make arrangements based on that, and we will do the best.
Okay. Thank you so much.
Thank you. Thank you.
Thank you. Our next presenter for today is Karthikeya Panikar, who will be presenting Knowledge Verified Visual Diagnosis, a retrieval-guided, refusal-aware computer vision framework for plant disease detection. You may now begin.
Yes. Is my screen visible?
Yes, it is.
Okay. Hello. Yeah. Am I audible also?
Yes, you are.
Okay. Is my screen visible? Because
Yes, it is.
I'm not able to see it on the screen. Okay, moment. Yes. Good morning, everyone. My name is Karthikeya Panikar, and I, along with my teammates Drishya Agarwala, Adrish Badra, Krit Prasad, and Professors Dr. Neha Ahlawat, Dr. Franklin D. Vinod, and Dr. Jaya Sharma, are here to present our research topic, Knowledge Verified Visual Diagnosis, retrieval guided refusal aware computer vision model for plant detection, disease detection. Yes, so our research focuses on improving the overall reliability of our AI-based plant disease detections.
Just a sec,
Yeah,
Karthikeya, can you go full screen?
sure, ma'am. Yes.
Yes.
So while the modern computer vision models achieve very high accuracy under controlled conditions, they often become overconfident when they are presented to unknown or poor quality of images, and also leads to hallucinations. So in order to solve this problem, we have developed a hybrid framework called Green Thumb AI, which combines the computer vision with RAG module. So instead of trusting blindly on CNN predictions alone, our system also verifies the prediction against scientific agricultural knowledge obtained, which is backed by IPO Global Database. We also have introduced a refusal away decision gate at the end of our flow. So this basically does is that when there is sufficient evidence is not available, so the system refuses to make a prediction. So instead of producing an inaccurate diagnosis, our gate makes sure that it checks the output that we have gotten from our CNN and also based from the LLM that we got, and it predicts below. If we get a prediction below the threshold of 0.70, so it basically displays that the output may be not correct or not be uh, exact. They would not be exactly directing to it, but yes. So these are the basis on three gates. Yes. Next, going to the project overview. So basically, the plant disease significantly affects our agricultural productivity and food scarcity. So existing deep learning models perform well on benchmark data sets, but they usually stop predicting after the disease classes. They do not explain their predictions, verify with agricultural knowledge, or even handle uncertainty. So our proposed framework addresses these limitations by combining visual learning with scientific knowledge and verification. The two major innovations of our work are retrieval guided knowledge validation system and a refusal mechanism that prevents unsafe prediction. So, although the plant disease classifications have a lot of challenges, firstly, the existing systems that are there only provide disease name without explaining why the disease was predicted. Secondly, they do not validate the predictions using agricultural knowledge. And then there are also models that are overconfident even when the image is completely unfamiliar or there is a noisy data given to them. And then finally there is no mechanism available to predict with uncertain predictions, which can lead to incorrect farming decisions and economic losses. So the objective of this research project, is to make the plant disease diagnosis more reliable and trustworthy. We aim to develop a refusal guided system that combines image analysis with agricultural knowledge. And this is the literature review. So we have gone through several papers which involved CNN, vision, transformers, mobile net, ResNet, RNN approaches. Most of these models achieved high classification accuracy under controlled conditions, but in most of them, they shared a similar limitation. They relied entirely on visual information and had no knowledge verification and always produced a prediction regardless of uncertainty. So this is the research gap we identified. The existing vision models only lacked factual agricultural knowledge. Current system always forced a prediction even when the model is uncertain. Standard CNN do not include any explicit or uncertainty handling or refusal mechanism. And finally, the black box classifiers provide a very little explanation to the user. So directly jumping to the proposed system. So to overcome this limitation, we have designed our system in which firstly the image is analyzed via CNN module, which is we have picked an efficient net BO. This is a pre-trained model. The predicted disease is then first verified using semantic retrieval from EPO knowledge database that is stored from ChromaDB. Then after the CNN gives out a prediction and output, it goes to a rack system where firstly the output that we got from the CNN is converted into prompts by calling an LLM. And then the whole RAG flow is initiated, where the LLM is provided with the overall analysis that was made by the CNN part, and along with the outputs that is got and the user query, the user image that was given, it is sent to the LLM. LLM then, based on its knowledge base, it retrieves the knowledge semantically based on from the query that was given, and every information related to that query is extracted, and then after uh, analysis, the LLM comes to a conclusion whether this plant disease is exactly this, or the CNN might have concluded with some other existing disease. And after that, the after the flow from the LLM, it goes to a refusal gate. So in that, if the score is below zero point 0.7 threshold, the prediction is above 7 threshold, the prediction is accepted, and a local model generates an explainable expert value. Since the entire pipeline runs on local using 5.3 Mini, the framework is secure, offline capable, and is suitable for edge deployment. So this is the whole system architecture. Firstly, visual analysis. Image is uploaded by the user and is processed to CNN, where we get the predicted disease classification and classes and visual features. Then in the second stage, the predictions are converted into semantic queries and is fed it into the RAG flow, into our LLM flow, and from there the we it generates an evidence-based diagnosis report, and finally at a refusal aware decision gate, it validates the consistency between the visual prediction and the retrieved knowledge before accepting or refusing the diagnosis. So this is our methodology. It consists of 4 stages. Stage 1 is our
Excuse me, I'm so
Yes.
sorry to interrupt. You have 1 minute left.
Okay, no issues. So in which we have process our image. The image is resized to 24 by 24 pixels and applying ImageNet normalization. In the second stage, visual analysis is done by a CNN efficient MBO. And in the final, we have deterministic vector retrieval, which is done. The Chroma DB is used as for semantic retrieval and query searching. And we have decision gate and logical synthesis, which calculates overall score based on label matching. This is the dataset that we have used. Our visual datasets come from the plant disease dataset, which is picked up from Kaggle. It consists of 38 plant disease categories. The textual knowledge base that was constructed was using an EPO global database, which provide an authoritative agricultural information. These are the tools and technologies that was used in order to implement. Python and Torch was used for utilize and loading executing efficient, lightweight, efficient, and convolution network. And we have used Olama in order to execute a 5.3 milli LLM entirely, which was deployed on our devices. And this is the screen that the user would be able to see, and in which we will be able to either use our camera to upload a leaf image, or we can upload it via the in stored device storage. And this is the algorithm output that we got, in which it was able to CV was able to determine the top 3 prediction, gives the top 3 predictions, and the most confident that was it shows, and along with we got the reasoning and the treatment and prevention causes was also given. This is the training and validation accuracy that we got. The overall performance metrics was the accuracy that were measured, all were correctiveness. The precision evaluates how many predictions were actually positive and are actually correct. F1 score balances the precision and recall. So in the result discussion, our efficient net model achieved approximately 99% validation accuracy. The confusion matrix shows that diagonal dominance, indicating an excellent classification performance. More importantly, our refusal-aware decision gate successfully intercepted ambiguous and out-of-distribution inputs. So, unlike any conventional CNN that always predicts a class, our framework refuses uncertain prediction and provides evidence-based explanation grounded in agricultural knowledge. Yes. So, in the conclusion, our research successfully combines the deep learning with retrieval augmented knowledge verification to create a more trustworthy platform, plant disease. Rather than blindly just predicting a disease, the framework it is actually validates its prediction using scientific knowledge. And the former, we will be also expanding this idea in order to make it a app so that every farmer and other people can be able to use our app. So these are the references that we got, and thank you.
Thank you, Karthike.
Yes, ma'am.
Very useful website or model or app which you are making. Just one question. You said you have used RAG in it.
Yes, ma'am.
So, what RAG did you use? Hard RAG or soft RAG?
Ma'am, we used soft drag in it.
And how did you integrate to it to get the data or the training data?
So, ma'am, basically, in this, from the base, we have created a knowledge base. So, the LLM is given a entire data set which is based on agricultural and plant information. So, we have used EPO data set in it. So, EPO data set is basically an international organization which have tons and tons of information, and they keep on updating those information into a data set. So LLM uses that information as its knowledge base. Then the output that we get from our CNN workflow, that is the predicted disease classes, and it also gives feature highlights like what features were found on the image, like for example, spotting on leaf, etc. So all of that is converted into a query. As we cannot give directly to it the LLM, so firstly we convert it into a structured prompt by calling the LLM. So after generating a structured prompt, the data is feed into the LLM. So along with that, it semantically it uses those query in order to firstly fetch all the data. So there's a data workflow agent. So it fetches all the data from the knowledge bases. Now, and based on that data, we have our knowledge base data, and based on the CNN classification, the LLM is able to put through an output.
All right. Thank you.
Thank you, ma'am.
Yeah.
Thank you. Now let's move on to the next presentation. Our next presenter for today is Nishant Kumar Gupta, who will be presenting lightweight inverted residual networks with efficient attention for mobile rice classification. You may now begin.
Hello everyone. Just a second.
Hi Nishant, are there any issues?
Hello.
Yes, Nishant.
Am I audible? I'm sorry, I was thrown out of the meeting by mistake.
Yes, you're audible.
Yeah, let me share my screen. Oh, oh,
Please begin with your presentation. If there's any technical issues, we can move ahead with the next presentation and circle back to this one. Is that all right?
I think he's dropped out of the
Yes, yeah.
meeting. We can take another one in the meantime.
We'll continue with the next presentation. Just one moment.
Hello.
Yes, Nishant, are you able to present now?
Yeah. Is my screen visible? I'm sorry.
Yes, it is.
Yeah. What I was saying is, presentation is about a lightweight inverted residual network with efficient attention mobile rice classification. This is my honors research project. So coming to the abstract, uh, we have built an optimized CNN that classifies rice grain with 96% accuracy using a fraction of parameters of existing models. So specifically, lightweight RiceNet combines MobileNet V2 style inverted residuals with two attention channel, that is ECN CBAM for 8 classes of rice variety. It reaches 96% accuracy with 1.4 million parameters and 0.5 G flops, which is 51 to 92% cut down in parameters and 43 to 90% cut down in flops uh, compared to other previous models. Yeah. So the challenges we faced is traditionally the challenges and like motivation we have is traditionally rice classification was manual observation work, and which is time consuming and dependent on human expertise. An existing deep learning model like RiseNet are computationally expensive. So our motivation for this was to build a scalable solution that bridges the high performance computer vision with practical and low resource agriculture environment, and focus on smart farming and precision agriculture. So key objective is to we have three objectives. First is efficient architecture. We wanted to design a lightweight RiceNet model such as it can be deployed on smartphones and embedded systems. Hybrid attention integrates EC and CBAM mechanism for fine-grained feature extraction and high performance, that is to achieve greater than 95% accuracy while minimizing the parameters and flops for inference latency. So this is the literature review. So in literature review, we have taken into consideration methods like SVM and LBP or KNN, which gives 85 to 89% accuracy, but are handcrafted and poor generalization. Then we saw that VGG, ResNet 50 or MobileNet are giving a better accuracy, but the parameters they use are 25 to 138 million. That is too heavy amount of parameters, and lack of attention on fine grained cues also. So next, coming to shuffle net or efficient net or fast net methods, their limitation, they have strong accuracy and low memory and cost, but the problem is the fine grained rice discrimination is reduced, and it cannot be scaled or not be deployed on edge devices. And the closest we can get was CBAM Paranext model, which is 94 to 94% accuracy with 2 to 18 million parameters. But the limitation was a uniform attention placement is not there, and it is still a heavier model. So we needed from this our gap was identified. We need to build a smaller model. I mean, not smaller but less heavier model in terms of parameters or flops, which can be and to have a better accuracy than these models, which can be deployed on mobile or edge devices. So coming to methodology, we collected first data that was 30,000 images across 8 rice categories. Then pre-process was done, like resizing, normalization, etc. Then architecture use was MobileNet V2 inspired inverted residual block with attention in channel involved. This is our own architecture built on top of IRB architecture. So training, we use different we use different things like Adam optimizer, cosine annealing, label smoothing. The dataset distribution is like this. Normal rice is highest in count, which is a normal scenario, like real-time scenario, and there are eight classes of rice distribution, like long, dense, short, dense, broken, unique, miscellaneous, etc. And it was divided upon among 70% for training, 10% for testing, and 20% for validation. So this is the model architecture. Overall architecture involves 34 layers of uh, 34 layers in total, of which the blue ones are inverted residual blocks, red ones are convolutional attention mechanism, uh, CBAM, and green ones are ECA. Yeah, so this is the inverted residual block. It what does is it expands pointwise and uh, then does the classification, and then again uh, pointwise projects it to next layer, and the input is also passed as output to the next layer, and also the output of IRB is passed to output of next layer, so it gets two output from one IRB, and it calculates the weights based on that. So the core components are three convolutional layer for low level feature extraction, multiple IRB adopted from MobileNet, as I said, and IRB are used to IRB uses depth-wise separable convolution, linear bottleneck, residual skip connection, and expansion ratio was used for balancing efficiency and accuracy. Then classification. So attention mechanism use was two type of attention mechanism integrated as a hybrid one. The first is ECA, efficient attention channel, which integrated in intermediate stages to enhance the channel-wise feature representation, and it uses a low parameter overhead. And the second one was convolutional attention module, uh, which is applied in middle stages and final stages, which perform both channel and spatial attention and improves the fine rise quality discrimination. So this is the mathematical formulation for it. Just to briefly, ECA computes the channel descriptor via global average pooling and passes it through a 1D convolutional and applies a sigmoid gate with kernel size close to adaptively based on channel count. So there is no manual intervention. The input itself is the so output itself of previous blocks is input for ECA. And for CBAM, there are two shared MLPs. First, which is used for channel attention, and second used for spatial attention, and both have average and max pooling involved in it. So this is the architecture. Yeah, so we were able to achieve this all architectural design of 90 and 96% accuracy with just 1.4 million parameters and 0.56 G flops, gigahertz. So comparative analysis, yeah. So it the cut The right weight lightnet performs 96.06% accuracy compared to its closest being CBAM PavNext, which was our base model for this research, which is 94.56 accuracy. So we are able to cut around 51 to 92% in parameters and 40 to 90% in flops with comparison to baseline model.
Excuse me, I'm so sorry to interrupt. You have less than a minute left.
Yeah, sure. So this is the comparison. So rice weight lightness gets the best accuracy. Precision and F1 is also better. F1 precision matters in this case as we are classifying uh, each of the rice grain, and parameters is the least compared to others. That is 1.4 million parameters and zero point 0.5 gigs of flops, and we are able to conclude the all this in less than 6 MB of size for the model. So this is we can conclude that this can be deployed in mobile or edge computation devices. So, so this is the training convergence. The model shows minimal gap between training and validation sets, and it shows a strong generalization. This is our dip, this is our UI, which we have built up on top of it. And system evaluation advantages is it has high accuracy across all the 8 varieties of rice, extremely low memory footprint, real-time inference on mobile device, and scalable to other grain types also. And current limitation are it is sensitive to uncontrolled lights because the data set used was uh, had all the rice grains taken in control environment, and focuses on classification and not defects, so we can include it in future uh, versions to class get the defects and all. And it uh, and another limitation is it requires diverse real world environment for data for commercial use. So uh, yeah uh, yeah, for deployment benefits are lower cost and fits in any app, and real time inference, and it enables automated grading to rural farmer, and then supports regional specialization infrastructure. If there is lack of infrastructure, this can be used as a alternative. And in conclusion, yeah, it has a better accuracy with less parameters and flops, and it can be used for agricultural vision task. Yeah, thank you.
Thank you, Nishan. I just wanted to ask, you have used hybrid attention modules in it,
Yeah.
ECA and CBAM. So, have you identified or found that what is the contribution of individual module in your complete architecture?
Yeah, so ECA basically is to get the yes, sorry. Um, so ECA basically gets the overall channel wide depth for features, and CBAM gets the channel and spatial depth combined. So we are able to cover different type of features like edges or uh, uh, like
Right. I just wanted to know the amount of contribution. You
edges or
can think of it later and incorporate if you want.
yeah,
And have you
sorry.
conducted an ablation study to justify the use of both?
Yeah, we have earlier models which were built on ECA or CBAM, but the ECA. So actually, CBAM was to get spatial attention more properly in our model, and ECA to get the like channel attention, but the other channel attention models cost a lot of parameters. So we have incorporated ECA in the middle layers of the starting layers of the, I mean, sorry, with, so we are able to get lesser parameters involved through getting both involved in it. And we have done modeling using separately also, like just TC or just CBAM, and we were not able to achieve much of good accuracy in it.
Perfect. Just, I think it will be good to conduct the ablation study. Like if you we've conduct the iterative experiments where you remove one of the module and check what other module is doing. I think that will give a justification for use of both and make your study a little stronger.
Yeah, sure.
Thank you, Nishant. That's all from my side.
Yeah, thank you.
All right. We'll now move to the next presentation. But before that, I just want to remind everyone to please stick within their time limit of 10 minutes. Our next presenter for today is Arya Gowde, who will be presenting Marine Spill Predict, Deep Lab V3 plus UNet and Hybrid for robust oil spill detection in SAR imagery. You may now begin.
Am I audible now?
Yes, you are.
And my screen is visible?
Yes, it is.
Okay, sure. So just a second. So now it's visible?
Yes, it is.
Okay. So good afternoon, everyone present here. So I am Arya Gowde, and today I am presenting research paper titled that is Marine Spill Predict, a predictive deep learning system for oil spill detection and environmental impact analysis. The objective of the topic of the work is develop an AI-based system that can automatically detect marine oil spill using satellite SAR images and generate an alert for the faster environmental response. So the content we are going to see throughout this PPT is problem statement, introduction, motivation, literature survey, gap analysis, data set description, methodology, result and performance analysis, conclusion, and reference. Now let's begin with the problem statement. Marine oil spills are among the most serious environmental disasters. They damage marine biodiversity, fisheries, tourism, and coastal ecosystem. So the traditional methods rely on manual monitoring. These methods are slow, expensive, and require expertise. Environmental conditions such as sea waves, cloud, and extreme climatic condition can reduce the detection accuracy. Therefore, there is a need for an AI intelligent automated detection system. So, we studied the new and interesting, unique marine oil spill project. So our proposed system use artificial intelligence and deep learning for automatic oil spill detection. Instead of depending on manual observations, satellite SAR images are processed automatically. The system identifies only oil region, estimated spill area, and generate alert whenever there is a high, large spill area detected. This helped disaster management authority to give the faster response. So coming to the motivation, our motivation comes from the recent incident of 2025 Kerala oil spill incident, where a leakage from a cargo ship MNC Elsa 3 threatened the marine life and coastal ecosystem. This incident shows that the traditional monitoring system can provide immediate detection. Therefore, we developed an AI-based solution that enable faster detection and early warning. So next slide. During literature survey, we studied a research paper from 2010 to 2025. So, in this research paper, in this study, we came across that earlier method mainly used SAR threshold, feature analysis, CNN, where each has an advantages but also a limitation, which also motivated us to develop a new system. So each approach has advantages but limitations such as low accuracy, high computational cost, noise sensitivity. This is covered in our project. So here is a gap analysis between existing system and the proposed system. The existing system suffer from several limitations: user-friendly monitor, automatic alert generation, and awareness model. So the proposed system has a simple user-friendly marine pollution monitoring platform. Many oil monitoring systems do not provide quick alert notification mechanism. Existing system also lack integrating dashboard combining alert, newses, and awareness features. So coming to the next slide, now I would like to explain the methodology and architecture of our proposed system, that is marine spill predict. Our system began with collecting SAR satellite images from the publicly available datasets. We selected SAR images because they can capture the Earth's surface in day, night, as well as in cloudy condition and extreme weather conditions, making them highly suitable for marine oil spill detection. After collecting the images, they are gone through the pre-processing stage. In this stage, all images are resized into 256 pixel values and the slack noise is reduced. This improves the image quality and help them to train and give result effectively. After a pre-processing, the pre-processed image is passed through two deep learning algorithms. That is, first is unit. In unit, uh, it has a encoder decoder architecture. For it accurately detects the boundaries of oil spill and generate a precise segmentation mask. Then coming to the second model, that is DeepLab V3 Plus. In DeepLab V3 Plus, we use Atrospital Pyramid Pooling, that is ASPP, to capture the multi-scaling contextual information. This helps the model to distinguish between the oil spill from the similar looking ocean regions and improve the detection accuracy. Instead of only using the one model, we combine the output of two models using a hybrid fusion approach. This combines units accurate boundary detection with DeepLab V3 plus contextual understanding, resulting in the more stable and accurate segmentation. Finally, the system identifies the oil spill region and estimated affected area. If the spill size is greater than the predefined threshold, the system automatically send alert to the authorities. These results are then displayed on the dashboard, helping the environmental agencies to take a quick response and reduce the environmental damage. This complete the methodology to make our system accurate, reliable, and suitable for intelligent marine spill monitoring system. So here is an architecture of overall methodology which I have just explained. So coming to the next slide, here is a dataset description. So our model uses multiple publicly available dataset. This dataset includes from Kaggle oil spill dataset, M4DT TIT datasets, SOS datasets, and Sentinel-1 SAR datasets. So overall, studying these datasets, we come across 19,000 images are used. So in this datasets, the images contains the this dataset contains SAR images, optical images, and ground truth mask, which is essential for supervised learning. Coming to the next slide. So here is result and performance analysis. Here is a performance of our three models, that is DeepLab V3, UNet, and hybrid model. Here the loss graph shows how error changes during the training. We can see that the training loss decreases, which means the model is learning correctly. Then in accuracy graph, it shows how many predictions are correct. The accuracy gradually increases and reaches about 97 to 98%, indicating the good performance. Among all these three models, the best is hybrid model because because it combines the strength of both unit and deep lab v3, which provides higher accuracy and more stable performance. Coming to the next slide, here is the comparison of output of our model. The first image is the original SAR satellite image. Then the second image is ground to truth mask, which is the correct oil spill region expertise, and the third is the prediction mask, which is generated by our model. Among all these
Excuse me.
three
I'm so sorry
models,
to interrupt. You have a minute left.
okay. Among all these three models, the hybrid model produce the closest match given the best results. Coming to the next slide, here is a model comparison using three evaluation matrices, that is precision, recall, and F1 score. Here, the precision shows how many detected oil spill pixels are actually correct, whereas recall shows how many actual oil spill pixels are successfully detected, and F1 balances both precision and recall. As you can see in this table, that hybrid model is the best for precision, recall, and F1 score, and more stable and accurate. The overall performance of hybrid model is most reliable model for marine oil spill detection. So now I would like to conclude my PPT. So our proposed marine spill predict framework successfully detected marine oil spill using deep learning. Then the combination of unit and deep lab v3 improves the segmentation accuracy, and the automatic alert generation enables the faster disaster response, and the overall system supports the environmental stability and marine ecosystem to protect through the intelligent monitoring system. So here is the references we have used in literature survey, and thank you. Now I would like to answer your question, ma'am.
Thank you, Arya. I think there's a final slide which you showed. You mentioned that results in the form of high, very high, and this. So can
Yes,
you
ma'am.
just throw light on what were the, yes, if you see here, your F1 score or recall or precision. So what was the range of the values which you got? So that for high, what was your range for very high, and how did you classify
Just
them into high, very high, best, or good?
so ma'am, so we first train the model accurately. Then while testing, we conducted a precision that three matrices evolution. So now yeah. So now
No, and I understood the method which you followed. I just wanted to know that when you were getting these results and you classified them, that you must have got some values so that you classified them into high, very high, best, or better. So, what were these values so that you can actually claim that there is an improvement over the previous model?
So values like so just a second, man. So values were using the formulas. For precision, it was like 70%, 70 to 80%. Then for recall, it was 20%. And the best, then the F1, it balances. For hybrid model, it gives us the accuracy of 97%. So, according to that, we have done this analysis.
All right. Thank you so much.
Thank you. We'll continue with the next presentation. Our next presenter for today is Soham Roy, who will be presenting MedInsight, a multi-agent framework for longitudinal clinical report understanding and healthcare navigation. You may now begin.
Sure. Let me just share my screen. Yeah. All right. Am I audible?
Yes, you are.
All right. So hi everyone. Um, on behalf of all the co-authors and myself as well, a very good afternoon to each and everyone present here. This is Shivam Roy, and I'll be presenting MedInsight, a multi-agent framework for longitudinal clinical report understanding and healthcare navigation. So, before we actually look into how exactly this works and all of that, let's take a look at the core capabilities of MedInsight. So, first of all, it provides a longitudinal medical report analysis. So it tracks patient health reports across multiple reports and visits and identifies different trends like key changes and critical findings as well. And finally, it generates a longitudinal summary as well. The second functionality it provides is a geolocation aware specialist search and ranking mechanism where it searches for the nearby specialist based on the user's location and the medical reports uploaded by the user and generates a top 5 ranked results as per the provider information. Finally, the context aware conversational assistance, which allows the user to perform retrieval augmented generation on the uploaded reports so that they may query whatever doubts they have regarding their reports. So that was the core capabilities. Now, before we actually look into the functionalities like in depth, we'll have to understand certain prerequisite terms to get a better scope, understand the scope of the project in better terms. First, are agents. Now, an AI agent is an AI system that can perceive or understand information, reason about a goal, and decide what actions to take, use tools, and execute tasks autonomously or semi-autonomously. The next prerequisite are multi-agent systems. Basically, these systems use multiple AI agents which perform a very specialized task. This allows the entire system to achieve a more complex goal by breaking them down into sub-problems.
Just a sec,
Yeah.
Soham. I think if you can focus more on the objectives and your the research which you did and the final
Oh, yeah,
findings.
sure. So, like,
Yeah, because we are
the
running
next
a
part
little
is
bit late, so I think if you can directly
sure,
go to
no
that.
problem. So, this is the overall architecture of MedInsight. The first, we have an head orchestrator. We have, all right, let's skip this part, and I'll explain the things with the help of a case study. So, the case study consists of an orthopedic case, which consists of 3 reports, uh, including an open reduction and internal fixation surgery, right? Uh, This is the agent state, which is basically a centralized context for the multiple agents. This basically acts as a shared memory for them. Each agent accesses the agent state and uh, basically updates it. So the first phase is the clinical report understanding part. So it begins with the user uploading the medical document. We have the OCR agent, which uses the easy OCR model to extract text from the uploaded reports or images. These reports are then uh, sent to the extraction agent, which works by using the text, passing the text as a prompt to an LLM and performing a one-shot LLM invocation. The extract to generate critical findings and extract laboratory values and metrics, which will be stored in a vector database for future reference. Now, the stored data from the database is accessed by the summarization agent, which also fetches the previous 4 reports. So basically, I'm working with 5 reports here. the current one and four older ones, and generate an overall longitudinal summary based on these reports. Of course, and the generated summary is then returned to the user as well, and it is further stored in the vector database. This is a sample output for the Streamlit based UI that we built. As you can see, this is the overall summary. Then we have the key changes, which compares the 5 reports we have taken earlier, and it also tells us the current values about the patient based on the report. The next is the specialist search and ranking system. So here, the we have first the user enters some kind of a query like something like search find me doctors or something like that. Now based on that query, we have a search term and location agent which extracts the most recent generated report summary from the vector database. It uses an LLM invocation to identify the uh, kind of doctor specialization that we need to search for. Then it uses a IP-based geolocation API to extract a citywide location of the user. Now, based on these two informations, we are generating a parameter. So basically, we are generating a search parameter. For example, if we are searching for an orthopedic surgeon, that is the doctor specialization, and we have the location as let's say Chennai, then it will be orthopedic surgeons in Chennai. So that was that. Now the search agent uses these parameters to scrape Google Maps data and extract doctors or specialist values via regular expressions and pattern matching, all that. Then we perform a min-max normalization to fit the value between a 0 to 1 scale rather than like a randomized scale that would be difficult for us to handle. Further, score we generate a composite score based on the number of star ratings the user has, I mean the specialist has, and the number of reviews the specialist has, and we allow them some kind of a bias from a 0 to 1 basis, and thus we get a top 5 specialist ranking, which is basically sorted in descending order, and we get the top 5 ones. This is a sample output of what the output looks like from the Streamlit UI. Okay. Now that we have looked into the first two functionalities, this is the final one, the context-aware conversational query. So the user enters any kind of query like how long do I will I take to recover from this, and so anything like that. If in case it is a voice-based query, or the user attaches some kind of a voice file, first the STT agent triggers, which uses STT agent means speech to text agent, which uses the OpenAI Whisper model to extract to basically transcribe the audio file to a text. The text is then sent to the chat agent, or in case the user passes a normal text, that too is sent to the chat agent. The chat agent performs fuel augmented generation by basically performing a semantic retrieval on the uploaded findings, which are stored in the medical like the vector database. And based on those
Excuse me.
findings,
I'm so
yeah,
sorry to interrupt. You have 1 minute left.
no problem, almost done. So of course, after that, it generates the response to the user. So this is a sample output, how things look, right? And yeah, this is the comparison with existing systems. Now we compared with existing systems like DXGPT, Docker AI, which are openly available to the users, and performed a capability-based comparison. Most of them do not provide any kind of specialist recommendation or retrieval augmented generation-based querying, and also they do not provide any kind of longitudinal comparison as well. So as for the future scope, we will be shifting to a more device-specific location extraction, web-based or maybe application-based UI, and we are trying to incorporate more specialized agents like agents for analyzing medical imagery or radiology in the future. So that was all for the presentation. Thank you.
Thank you, Soham.
Yeah.
Good presentation, and I think no questions from my side.
Okay.
Alicia, we can move on to the yes.
Thank you, ma'am. Our next presenter will be Siddhanshu Gunge, who will be presenting Sea Level Monitoring Dashboard, a data-driven approach using Power BI for climate insights. Please keep your presentation crisp. You may now begin.
Yes, ma'am. So can I share?
Yes, you
Okay,
may.
fine. Just I am sharing the screen. Share. Okay, fine. Python code is also there. Okay. So the sea level monitoring dashboard, why there is a need? Actually, this project was being done on the Power BI dashboard by my students Shreyas, Srehan, and Amaya Sulna. So these people are working as an interns, and they are thinking that they are supposed to have a particular approach that any human being or who is a living being on the earth must have an early warning system about the climate insights. So here the sea level is critical and consequence climate changing affecting the million of people living coastal region. As we know that the geopolitics is going on, that a lot of things are going all over the world in the real time scenarios across the multiple sources. This is lack of integration limits effective decision making, and that's why we are facing a lot of problem in the rainy season as well as in every season like summer as well as in the winter also. The study addresses the gap of creating the unified and interactive dashboard consolidated about the data which are in the diverse data set into a single and user friendly platform so that the inference can be taken out. That was the problem. Yes. So what will be the sea level? What will be the sea level and high tide, low tide? How the different types of seas having the anomaly that can be find out. The main objective of our research was to design and develop the interactive dashboard that integrates the observational and predictive sea level. What happens if there is a war? Then whether the sea level will increase, what will be the glacier tides? Everything we have to understand because it is one of the important aspect currently going in the world. So that we have to understand. It aimed to harmonize the data set, visual trends, and provide the forecasting of the capabilities. Additionally, the system focuses on the improvement of the accessibility, ensure that the complexity of the scientific information can be understood easily and understood by the stakeholders. Yes, everyone in the real natural world that is a stakeholder. Ultimately, the goal is to bridge the gap between the climate, yes, along with the actionable insight for planning and decision making. So what are the action plan we have to do? So dashboard is integrated with the multiple authoritative data set to ensure the accuracy, reliability. Again, we have utilized some of the organization for ingestion, such as here we have taken National Oceanic Atmospheric Administration, then National Aeronautic and Space Administration, European Space Agency, which is available freely on their sites for a range of 2015 to 2024. So gravity recovery climate experiment, we have understand and follow up their work ocean heat content because the global navigation satellite system always provide about the ocean where will be the climate change. So again, informametric synthetic aperture radar system, then intergovernmental panel where the rainfall, hot, humid, and what will be the oxygen rate, what is the ozone layer quality. So everything will be worked out by using the six assignment report and the vertical land motion. Yes, day by day we are losing our land. That is also one of the aspect. So here the scenario of the data set was being used for forecasting. This combination enables the comprehensive understanding of the both global regional sea levels. It is not only single sea level, but entire earth. So here data pre-processing was one of the technique that we already utilize in the data science and for the and their harmonization for getting the correct insights. To ensure the consistency of the data set, undergo to the proper and rigorous pre-processing so that the illegal values should not be there, missing values should not be there, or any missing value, as well as we can say that the wrong input should not be processed so that we can get a wrong insights. Unit are standardized. Yes, we are taking in the millimeter. Even though the rainfall is high, we have to calculate and we have to make it standardized, and normalization we have to do, and the time series that the data is aligned across the platform. Vertical land motion correction are applied whenever available, improving the accuracy for the local measurement. Uncertainty tracking is maintained throughout the pipeline to preserve the scientific integrity. This structure is pre-processed, ensure that the final dashboard outputs reliable, reproduced, and suitable for the decision-making purpose. Currently, many of the people are facing problem in Mumbai right now. But if we have a dashboard, the early warning system, the people can take the decision for fast moving away from the sea levels or coastal regions. So these things are necessary in a real-time
Just a sec,
part.
sorry
Yes,
to
ma'am.
interrupt, sir. As the session is got very late, can you just speed up
Okay.
and come to the...
Yeah. The system architecture is one of the part that here the system, the data ingestion, we are collecting the data from the government organization. The pre-processing and harmonization is being taken with the help of the Python, and the particular component decomposition, budget closure, and the vertical landmark we have to understood. Then we are storing our data into a particular data set where the version controls and the notebook along with the GitHub we can use, and the visual Microsoft Power BI. But when we are storing everything on the GitHub, we should have the analytics and the forecasting by the statistical trends and the estimation, linear and losses, and scenario envelopes that are being considered along with the optional ML forecasting model, so that we can get a proper visualization of the particular Microsoft Power BI, which is interactive forecast and uncertainty bands. That data can be exported with the help of CSV, or we can use the PNG value. So the end user can able to do some kind of research, policymaker, coastal administrator, educator, student, and any people on the earth can work on that. So these things are very important. The dashboard overview is very important. We have taken the anomalies between the 2015 to 2024. The visualization highlights significant variation across the region and with the Arctic, Pacific, and showing the highest anomalies, because this is the graph of the world map. And this overview serves as another foundation for the further analysis, allowing user to identify the pattern comparison and explore the trend over the time throughout the interactive controls. So this interactive control, if you want to see the any point of the sea, then we can have that. So the sea having the different trend: thermal expansion, glacier melt, ice sheet loss, the total sea level anomaly over a time, reservoir, maybe of river or lake, the conflict or driven impact, everything will be calculated in the particular These things are very important to understand for our general common person. The sea level changes very significantly across the region due to the ocean circulation and the climate pattern and the land movement. So if you observe that the ice sheet is very small, but the green sheet is very big, that is thermal impact. That Baltic Sea, Indian Ocean, Central Pacific, North Atlantic and Delta, South Pacific, Arctic, Mediterranean, Caribbean, and Southern Ocean is having the maximum impact due to thermal. Whereas the ice glacier sheet is from 6,000 to 8,000, means around 2K is been the part, whereas the glacier impact is of 4K. So this is an
Excuse me.
analysis for this thing.
I'm so sorry to interrupt. You have 1 minute left.
Okay. So this is nothing but the anomaly where we have to concentrate. So there are the total 5 stations by the sea level anomaly in in that has been calculated, that having the total value 1 crore 38 lakh for 489.10. So the glacial isolation adjustment is one of the part. So These things are being calculated for understanding the early warning system. The dashboard decomposes the sea level changes into the contributing the factors such as the glacier melt, thermal expansion, and anthropogenic influences. So the as the illustrated figure differently regions which are available in the sea area, that is Arctic Central Pacific, in which we calculate the anomaly of minus 234.84 value, and that has been found if we take the average of all seas. The detailed breakdown of the enhanced understanding of how the natural and the human-driven process interact, providing a more comprehensive perspective on the climate dynamics. So this was the forecasting that we find, and based on that, what is the total anomaly is being observed all over the world, but for a prediction of 2025. But right now we are in a 2025, still the work is going on to identify. This is with respect to the consistent with the IPCC scenario. So here regional forecast comparison is being done for the different points of the sea, where we find that the particular Mengod delta is mean more polluted and having the more anomaly and rise in the sea level as compared to 2024 and 2025. So external environment and the factor are very important, like atmospheric pressure, and then again the smaller impact and the element enhance the comprehensive for the analysis and improve the overall accuracy of the dashboard. So this was from our research work that was approximately 3.3 mm per year the water is rising. Second, the local factor of such of the land subside. So subsidence in the amplifying the risk, and by integrating the multiple data set into a single platform, the system enhance the understanding and the provide the actionable insight for the climate adaptation and policy planning. This is from our side. So from conclusion, I want to say that the dashboard is one of the important part of our day-to-day life, so that people can get a climate data into an actionable insight, and again which serve as a scalable extensible framework for the environmental monitoring. And here also the same picture I have taken to reflect here what we can do. They include the machine learning based prediction learning from the real-time data and integration and incorporation of the social economic indicator for improvement of the system, which can provide the further ability to the support decision making system related to the climate and different strategy for the global sustainability. So thank you from my side. If you have any question, ma'am, you can ask me. So these are the references.
Just one question.
Yes.
How do you validate that the information which is reflected on your website is accurate?
That source we have to take it from the government website, like we have ISRO or IITM, that is Indian Metro, that calculates the temperature for every city there is. So we can connect with them and it can be a part of your system. Always they tell that what is the ice level. Always they tell that what is the sea level, water level, prediction algorithms. But it should not be only up to the government. It should come to the smartwatch just like in a dashboard. Right now I am in Pune, so that's why I can see the temperature of Pune. But if I am going to Mumbai, what will be the sea level for Mumbai? Yesterday there was a lot of rainfall, so people were suffering. So what is the Arabian Sea level right now? So the people doesn't have that much sense, but we have to make them aware about it. So dashboard making of multiple water level is very important for climate insights. You can also make for the AQI index and other stuff, but for water we have think for the sea level, because lot of pressure is there, lot of things are happening, volcanoes are coming in the sea. So this is one of the aspect for nature that we have considered.
Thank you, sir. Thank you so much.
All right. We'll now move on to the next presentation. Our next presenter for today is Harry Friedrich Rakota Malala, who will be presenting towards an implicative, minimal, acyclic, directed graph according to MGK. You may now begin your presentation. Please make sure that you keep it crisp.
Can you hear me?
Yes, we can.
I see my screen.
Your screen is visible. Please share the presentation.
You see my screens?
We can see your screen, but we can't see your presentation. Okay, now we can see. Yeah.
Okay. No.
Excuse me. I believe you're playing a video, but it's not audible. We would appreciate it if you could present.
It's not audible?
No, it isn't.
Excuse me.
Excuse me, sir. I just want to remind you that due to the time limit, we really need to rush with the presentation. We would really appreciate it if you could wrap it up in about 5 minutes or so.
What?
We're facing a time crunch right now. We would really appreciate if you could begin quickly and wrap it up within about 5 minutes.
Okay. Hola. Where is not I can screen my I can share my screen, please. Hola.
If you're facing any issues, you can send me your presentation. I can present on your behalf and you could tell us about your paper.
Mm-hmm. Hola.
If you're facing any technical issues, that's all right. We have another presentation to complete. We could do that and then get back to you. Is that okay?
Okay.
All right, thank you. One moment, please. I'm so sorry, there seems to be some issue with my laptop, but our next presentation will be by Chavi, who will be presenting Unmasking the Traitor, Detecting the Dishonest Nodes in a Distributed Cyber Fiscal System for Fair Elections. You may now begin your presentation.
Alicia, I think the presentations were over, no? This was the last presentation.
Yes, ma'am. I'm sorry. There's been an order that we have to take another presenter as well. So we'll just
Okay,
have to
because I
compare.
have a class scheduled. It is already 20 minutes post that.
Oh, yes, of course. Just one moment. I'll just get that confirmed. I'll let you know. I'm so sorry for the inconvenience.
If not, I'll send you my presentation. Hola.
Excuse me, Chavi. Please, we request you to stop presenting for a moment, please. I believe Harry has left the meeting. If any of his co-authors are present, we can continue, else we could end the session. All right. In that case, I'll move towards the closing remarks. One moment. So I sincerely thank all of our authors and for all of our authors for their excellent presentations and contributions in this session, and all of our participants for being a part of this international conference. I do apologize for running past the time limit, but I hope this session was informative for everyone. And on behalf of the entire team, I thank you for your support during this 11th version and all of the previous 10 versions of the conference. We will be happy to have you in the 12th version in 2027. All of the presenters will receive their digital certificates within the next 2 working days via email, and the publication will be live in 7 to 8 months. Kindly cooperate with the team of ICT4SD 2026. I would also like to thank our session chair, and on behalf of the team, I would like to present them with a token of our appreciation. One moment.
Thank you, Alicia.
Yes, ma'am. Just 1 second. All right. Thank you so much, ma'am. Thank you so much for chairing the session. And once again, we apologize for the inconvenience.
Thank you. Thank you so much. And I'm really sorry. I had actually kept a buffer of 20-25 minutes for the class.
No worries, ma'am. We understand. We're so sorry as well.
No, thank you so much.
Before we end the session, I request everyone to please turn on their cameras for a virtual snapshot. All right. Thank you so much. The session is adjourned.
Thank you.
Alicia, ma'am, I have sent you one message. Please go through it.
All right. Surely.
Can we leave?
Yes, you may.
Thank you.
So will we get Alicia, ma'am?
Just a
Hello?
second. I'm sending it over.
Don't send here. Can you send it to email? That will be great.
If you want that, you have to request an email to our support team. I'll just send you their email ID in chat.
Okay, just I will check your email ID. That will be great for us. Just 1 minute. Stay online. Okay. Can you send only that?
Just a second.
Okay, fine. Also, I have a second paper too, but I have presented there. That is this paper ID. There are two papers, you can say that. Okay. Definitely they will report. Okay, fine.
Thank you. The session is adjourned.